Number 2, a wonderfully contrived question. A scared kangaroo cleared a fence by jumping with a speed of 8.42 meters per second at an angle of 55.2 degrees. So some stuff that I already know. Initial velocity was 8.42 meters per second. Angle 55.2 degrees. If the jump lasted 1.40 seconds, how high was the fence? So, how high was the fence? And then what was the kangaroo's horizontal displacement? All right, so again, we have a two-parter here. Now, if we're looking for how high was the fence, again, that's going to be our y max. And we know that the delta t for a y max, right, which will go, just represent it that way. The delta t for the y max is going to be half of the delta t, which is 1.40 seconds divided by 2, which ends up being 0.700 seconds. So the time it takes to get to the y max, or in this context, the top of the fence, is 0.7 seconds. So when I go to use my kinematic, which is going to look like the sine of theta, and then what is my, oh yeah, it's going to be half of delta t plus 1/2 a, y direction. Again, half of delta t, and we're going to square that. So when I actually go to plug all this good stuff in, 8.42 meters per second, got that from the question. Sine 55.2 degrees, again, got that from the question. 0.77 seconds is my time because it's, again, half of the delta t given by the problem, plus 1/2. Again, I'm going to run out of space here. Negative 9.81 meters per second squared. And then it's going to be, holy cow, 0.7 seconds squared. All right, so I'm running out of time. It's a little bit sloppy. There you go. So when I plug this into the calculator, this is going to give me the fence is 2.44 meters high. Right, so how high is the fence? 2.44 meters. Now the second part of this question is, what is the kangaroo's horizontal displacement? Well, again, if I use this same kinematic, but instead of setting it up for the y component like I did here, and I set it up for the x component, remember, acceleration is going to be 0 in the horizontal component, in the horizontal plane. So I actually only have to deal with delta x equal to vi cosine theta times delta t. Now I'm in a position just to plug and chug. 8.42 meters per second. Cosine 55.2 degrees. And here, since the horizontal component doesn't just get to the top of the fence, it actually comes back down, we're going to use the entire delta t. And my calculator tells me that ends up being 6.73 meters.